is measure what we call the voltage drop across each component in our circuit. So as these electrons go around the loop, they are losing energy when they go through resistor number 1. They lose some energy when they go through resistor number 2, and the battery adds some energy again. So this is kind of like the escalator with the marbles we saw earlier. So what we want to do is figure out how much energy or how much voltage. So remember, voltage is just energy per charge, per coulomb of charge. So to do that, you're going to grab the voltmeter, which is over here on the left side, drag it maybe down here so it's out of your way. And then these two probes have little metal tips, and you got to put the little tip right on the ends of whatever component you're investigating. So if I put the left tip here and the right tip on that side of the battery, I can tell that across the battery, the electrons are gaining 60 volts of energy, or 60 joules per coulomb. Okay? So that's how we measure the voltage. If you wanted to measure the voltage on the current meter, you would put these on either side of the current meter, and you would see 0. They are not losing any energy when they go through the current meter. But if I put them up here on resistor number 1, so I got to move both probes so that the little pointy things are on either side of the resistor, you can see that we have 15 volts. So as the electrons go through this resistor, they're losing 15 volts in my example. It's going to be different in your example. So we are going to call the voltage that is lost, or the energy that is lost when it goes through this resistor, we're going to call that V1, because we call this resistor R1. So if this is resistor 1, the current that goes through it we call I1, and the voltage or the energy drop we call V1. Okay? If you wanted to find the voltage drop, or how much energy is lost on this resistor over here, resistor 2, you would bring the probes over here, put one on the left side of it, one on the right side of it, and you would see that in my example, I'm losing 45 volts of energy as the electrons go through here. And if you do it like just on a wire, then you'll get 0, because you don't lose any energy when electrons go through a nice big thick wire. All right, so when you want to measure voltage, grab your little voltmeter and just tuck it down there on the side so you can see it. You can actually put it anywhere you want, and then just put the probes, the tips of the probes have got to go on each end of the component you're measuring, and that will tell you the voltage, which is the energy either gained or lost. If it's a battery, the energy is going to be gained. If it's a resistor, the energy is going to be lost. And don't worry about if the voltmeter tells you negative. Like if you just get these probes backwards, you'll see this says negative 15 volts. Don't worry about whether it's negative or positive. That just has to do with whether the probes are backwards or forwards. What we really care about is the number. It's 15 volts, and since it's going through a resistor, we know it's lost. And if it was on a battery, we would know that it was gained. All right, so you're going to use that technique to find the voltage across several of your circuit components.